Hello everybody. In this video we shall learn about algebraic expressions. This is nothing but section 1.3 in your book. We need to learn about algebraic expressions for establishing higher mathematical proofs, like when it comes to pure mathematics and even in applied mathematics. We use some abstract tools that where this particular unit sets up a basic for learning all that. And also, if you want to model a real life problem and find solutions for it, you should be able to express the real life problem into an algebraic expression and know how to solve them so that you can give solutions for some problems that are that arises in day-to-day life. To begin with, let me define what is a variable. A letter that represents any number from a given set of numbers, like for example, what is a letter like X, Y, Z and so on. So such a letter is called as a variable. It represents any number. That means it can take any value of any number which belongs to certain set. Maybe it can be set of all natural numbers, it can be set of all rational numbers, set of all real numbers. So that is why the name variable, because it doesn't have a specific value. Its value can vary according to the situation. Next, I shall define what is an algebraic expression. If you combine variables with numbers, because we are working in real domain, that is, we are working with set of all real numbers, that number can be inside R and perform operations like all arithmetic operations or whatever operations that we know right now: addition, subtraction, multiplication, division, division and nth root of a number or power, etc. We get algebraic expressions. Like for example, first one, I will consider an expression with the variable x. If I consider cube root of x, I am performing the operation nth root on x and I am adding a real number. You can say how is this combined with the variable? So it has one of its factor, it is multiplied by 1, which is nothing but x to the power of 0. So a constant is also a algebraic expression. Second one, square root of x minus 4y. Here you can see there are two variables, that is x and y. So an algebraic expression can include two variables, and you are performing subtraction here and power here and square root, and you are performing division and plus 2 and addition as well. So all operations that we have learned till now, we have performed in this expression. Third, this is very simple one. I need this for explaining types. 9x to the power of 5, 6x to cube plus 4. This is also a polynomial. This is a simple one where we have combined x to the power of 5 with 9, x cubed with 6, 4 with x to the power of 0, and we have added them. Now let us see what are the types of algebraic expressions. Throughout the video, I will denote algebraic expressions by AE. That is my denotation, just to avoid more writing. Okay, first type, it is monomials. As the name itself suggests, mono means one. So an expression which has one term, that is, I'll tell you what is a term. Expressions of the form a x power k, where, as explained earlier, the coefficient a must belong to r. That means it should be a real number, and k is a non-negative integer. What is the difference between non-negative integers and positive integers and negative integers? As 0 is neither positive nor negative, if you say non-negative, it means that this particular set will include 0 as well as positive integers. And if you say only negative integers, it will include only negative numbers but not 0. If you say only positive integers, it will include only positive numbers but not 0. If you say non-negative or non-positive, that includes 0 as well as positive or negative accordingly. This is a monomial. Therefore, there is only one expression. So, second one, binomial. Bi means 2. So, here you are adding two monomials. So, sum of two monomials is a binomial. Third one, our numbering as well as the type is matching. So, trinomial. Tri means 3. Here in the same way as we did here. So, it would be sum of 3 monomials. I'll give examples. Generally, what happens if it is more than 3? So, generally we call such expressions, or generally we call all algebraic expressions as polynomials. We will define polynomials soon. We have specific name if k takes value 1, or if you have one expression. If you have sum of 2 expressions, if you have sum of 3 expressions, we have specific name. But in generally, we call everything as polynomial. Therefore, your monomials, binomials, trinomials, and if there are sum of more than 3, like 4, 5, and so on, everything is called as a polynomial. So, let us define a polynomial. Before that, we can observe here, this is a trinomial because you have third one. This is a trinomial because you have you are adding 3 monomials. You are adding 3 monomials, so that will be a trinomial. And this is a binomial because you are adding 2 expressions or 2 monomials, so therefore that is a binomial. So let us define what is a polynomial. A polynomial in variable x is an expression of the form, this is the general form, an x power n plus an minus 1 x power n minus 1 plus and so on plus ax plus a1x plus a naught. That a naught is same. You have x term here, but that is of the form x to the power of 0, and that is 1. You need not write 1. Where what are all these ai's? an minus 1 and so on, a1, a naught, they are all real numbers because we are still working with the real numbers. And n is a non-negative as defined in monomials, non-negative integer. So n can be, you can say that n can be 0, correct? And because all ai's are real numbers, an can also be 0. That means this term can totally vanish. So in that case, you need to be careful while defining degree. So I am defining degree here, that is degree of a polynomial. If an is not equal to 0, then degree of a polynomial is n. Degree of a polynomial is n. Therefore, if you have a monomial of the form, say 9x power 5, so this is of degree, this is the highest thing, like this, you don't have any other terms. All your a4, a3, a2, a1 and a0, they are all 0. So for this is a monomial, this has degree 5. And inside the polynomial, each monomial of the form, each monomial of the form ak x power k is called as a term. Therefore here, this is a term, this is a term, all these are terms in the general form. When you come to the examples that I gave above, so 9x power 5 is a term, 6x cube is a term, 4 is a term, because each individually they are monomials. Now let us work some examples. We shall write the polynomial first and its type, identify its type and what are all the terms and degree. So first one, 3x cube plus 5x minus 4. So here you have addition of 3 monomials. Therefore this would be a, what is its type? It is a trinomial. And what are the terms? What are the individual monomials that are making this whole expression? That is 3x cube, 5x, and you can observe the general form. You are just adding all the expressions. So when you have a negative sign in the last term, here -4, so that means you need to consider the negative sign along with the term, because that means that you are doing the operation like this, like 5x plus of -4, which matches with the general form. So -4 is also a term. and which is the highest number where n is taking the value, like highest monomial power. So that would be 3. So degree is 3 in this case. Second one, it is not necessary that everything is placed in order, as addition, addition and addition is commutative, and here all the monomials are being added. You can write the terms haphazardly, not every time in an increasing way of the powers. So for example, x square plus 8 minus x minus 0.5 x cube. So here 3 is of the highest degree, but that is not written first. So that is what I meant. And here there are 4 terms. Therefore, the type is four terms doesn't have a specific name. It is just a polynomial with 4 terms. And what are all the terms? You have x square, 8, and what is this? Negative x. You should take the sign along with the monomial, because it matches to the general way of defining a polynomial, and negative 0.5 x cube. And what is the degree? The highest power of a monomial is 3. Therefore, degree is again 3. So what about constant polynomials? So constant polynomials are just real numbers, where this is also a polynomial with variable x or any letter that you take raised to the power of 0. So this is all constant polynomials are of degree 0, and the term is just the number itself, and this is definitely a monomial. Or if you have a variable raised to a power greater than 0, so this is again a monomial with term 9x power 5, and the degree will be the highest power of which the variable is raised to, that is 5. Now I'll give you a quiz, that is 1.3.1. I know I numbered all the quiz questions in my previous video to be 1.1. I didn't realize that I was in chapter 1.2, but you can write your answers as I have numbered in the video, and as I have changed it to 1.3.1, you can number the answer of this question accordingly. Classify the following polynomials into monomials, binomials, and trinomials. The polynomials are: first one, negative 5 plus z; second, x plus y plus z; third, they are really easy, y square minus z plus 100; fourth one, ab minus ac; fifth one, negative 177. With classifying, I guess I will give you right there, write type, terms, or while classifying you will write the type, terms, and degree as we did above. Okay, so these are all the polynomials. Next we shall see what are like and unlike terms. If a term of an expression, that is if a monomial in an expression has the same variable and its power should also be same, but coefficients can be different. It should have a same variable and the variable powers should be same. but it can have different coefficients. They are called as like terms. For example, 5x square and negative 9x square. So here you have the variable also same, that is x, and powers also same. It doesn't matter if your coefficients are different. So these are like terms. Second example, negative 7xy and negative 5yx. You can say xy and yx are different. No, because xy and yx are real numbers, and real numbers are commutative in terms of real numbers satisfy commutative property. Therefore xy and yx are same. So variables are same, but it doesn't matter if the coefficients are different. So like terms are those. Now here comes your quiz 1.3.2, which is explain why the following terms are not like terms. I am going to give you unlike terms, like which are not like. You should tell me why. 7x, negative 7xy, 7x and 5x square. Now we shall see how we perform certain arithmetic operations or all the operations that we have learned so far with expressions. To begin with, we add and subtract polynomials using properties of real numbers that we learnt in the review video. Those are like associative property, commutative property, and distributive property. For example, I consider first one two expressions that I will be adding: 3x square plus x plus 1, which will be subtracted. Okay, subtracted with 2x square minus 3x minus 5. I want you to write which is the property that you use in each step, so that I can understand if you, whether you have learnt all the properties properly or not. You retain the first term as it is. You can see you are multiplying negative 1 over this expression, and each of the monomial is being added or subtracted. Yeah. Therefore, you operate the negative 1 over each of the terms. That would be distributive property. Hence, this can be written as plus of negative 1 over 2x square minus 3x minus 5. This is not altering the above expression. Now, apply distributive property for the second term. You will get negative 2x square, negative into negative will be positive, 3x, negative into negative again is positive, plus 5. Now what you can see, since addition is associative, you can remove the brackets. Like you can operate it as you want. And now addition is again commutative. If you using commutative property twice, if you bring 2x square next to 3x square, that means you are grouping all the like terms. You can see these two are like terms, these two are like terms, and these two are like terms. So therefore 3x square, I will group all the like terms together, and the property that you are using while bringing the like terms together would be commutative property accordingly, maybe once or twice. I'm not going to write that, but I want you to mention which are the properties that you use each step, at least with the first problem of your homework or quiz. So x plus 3x, I brought these two with x variables together, plus 1 plus 5. Now we can operate the like terms. So 3x square minus 2x square would be just x square, and 3x plus x would be 4x, and 1 plus 5 would be 6. So this is how you do the addition or subtraction operation. I will show you another form which is called as table method. Add or subtract using table form. So that is how you do it, like in lower classes, but that helps sometimes in polynomials until you are expert in identifying like terms if you write expressions horizontally. So one expression is this. The second expression is 4yz. So 4yz and 5yz are like. So I will write 4yz below 5yz, and 9zx. Plus 9zx. So 9zx will come here, minus 4y. There is no y term in this expression, therefore I write it outside the expression, minus 4y. And the third expression is minus 3xz. So we have xz here, minus 3xz, yeah, plus 5x. So again 5x is not in any of the thing, so I will write 5x outside all the expressions. I can write it towards the left side outside or towards right. I prefer right. Plus 5x minus 2xy. So this would be minus 2xy. Now perform all the operations vertically. 7xy and minus 2xy would give me 5xy. 5yz plus 4yz will give me plus 9yz. Minus 3zx plus 9zx would give me 6zx. Minus 3zx will give me plus 3zx or xz. And here it is nothing but plus 0 and plus 0. So 0 minus 4y plus 0 would be minus 4y. And plus 0 again. So 0 doesn't matter. So it would be plus 5x. This is the table form. Till you get acquainted with doing things or get expertise in solving expressions horizontally, I recommend using this method. Unless the terms are like too big and you can't use it. Okay, so now I'll give you quiz. You can use any method that I taught you to solve this. Subtract 4p square q minus 3pq plus 5pq square minus 8p plus 7q minus 10. This is a very big expression. From 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q. This is your quiz 1.3.3. Now we shall do multiplication of algebraic expressions. Suppose in general, we are doing multiplication of algebraic expressions. AE means algebraic expressions. In general, I take two binomials and try to multiply them. If they are of this form, in general form, this method is given in the textbook also. This is just for better remembering, like how to operate the expressions, how to do the multiplication. FOIL, which tells that first terms you should multiply first. That is, A and C are first terms. Then O represents outer terms. So outer terms of the whole expression is a and d. You multiply them. Then inner terms. I represents inner terms. Inner terms are b and c. And L represents last terms. So last terms of the whole expressions. Okay. Last terms of each expression is b and d. Therefore multiply them. So this is FOIL. This is very useful for remembering how you should multiply. What is the process you need to follow? Following this method, F represents first term. So I will multiply A and C plus outer terms A and D. That would be AD plus inner terms, that is B and C, BC plus last terms of each expression, that would be B and D, BD. So this is the method you follow when you are multiplying two binomials expressions. So you can say we multiply two factors by multiplying each term in one factor by each term in other and adding these two. This is what will give you the product. You can say like where do we actually apply the multiplication of algebraic expressions in real life? So suppose I give you an pattern like this and find out, this may be more in number. Find out how many dots I have placed on the board. If it is like too many, you just need to count the dots, number of dots in the row and number of dots in the column and add it. 4 cross 3, that would be totally 12 dots together. So what if these are algebraic expressions? Like if you want to find an area of a rectangle, so you use this, and area of a cuboid, you use multiplication of algebraic expressions. Well, now let us learn further. We can use distributive property and also rules of exponents while multiplying algebraic expressions. For example, in this video you learn many things just by examples. So you are learning many methods of solving algebraic expressions by examples. X plus 1 times 2x square minus x plus 1. So this is one expression and this is another. You need to multiply it. Let us apply FOIL method. Here the first term is x and 2x square. Therefore, okay, before we do that, this is a binomial and this is a trinomial. We cannot apply FOIL method here because there it was like two binomials, it worked, but this we cannot apply that method here. You can observe this whole expression can be treated as one expression. That means you should apply distributive property. You should distribute this one expression over each term of the x plus 1 expression. So that would give me x of 2x square minus x plus 1 plus 1 of 2x square minus x plus 1. So what is the property that we used here? Distributive property. Now again, applying distributive property to each of the terms, we get x times 2x square minus x times x plus x times 1 plus 1 times 2x square minus 1 times x, that doesn't make a difference, but and 1 times 1. Now simplify the terms. X times 2x square will give me 2x cube minus x times x, using the rules of exponents, bases are same and they are multiplied, so powers can be added. X square plus x plus 2x square minus x plus 1. Now group all the like terms. There is no term with cubic power, therefore 2x cube will stay as it is. You can group x square and 2x square, so minus x square plus 2x square, and this and this, that would be plus x minus x plus 1. Simplifying now, 2x cube, this would give me plus x square, that is 2 minus 1 is 1, x square, and plus x and minus x, they cancel out each other, plus 1. So this is how you multiply using distributive property and rules of exponents. And here comes your quiz. 1.3.4, that is 1 minus 2x times x square minus 3x plus 1. It is almost the same. You should be very careful with the sign while solving this. I will do something more complicated. This is exercise 52 in your textbook. So that would be question: x to the power of 3 by 2 times square root of x minus 1 by root x. So we know how to write nth power as powers of exponents, that we learnt it in the previous video. So therefore I can write the terms inside the braces as x to the power of 1 by 2 minus 1 by x to the power of 1 by 2. This will be equal to x to the power of 3 by 2 times x to the power of 1 by 2 minus, this is nothing but x to the power of negative 1 by 2. Now don't cancel out these two because the powers are different. One is positive and negative. They are totally different. Now we can apply distributive property. Distribute this x to the power of 3 by 2 over each of the terms inside the braces. So that is x to the power of 3 by 2 times x to the power of 1 by 2 minus x to the power of 3 by 2 times x to the power of negative 1 by 2. Now bases are same. You can add the powers. So therefore x to the power of 3 by 2 plus 1 by 2 minus x to the power of 3 by 2 plus of minus 1 by 2, that is nothing but minus 1 by 2. This will give me 4 by 2 minus x to the power of 3 minus 1 is 2. 2 by 2, that would be 1, that is nothing but x, and this would be 2. So this is x square minus x. So if you, okay, x square minus x, we shall leave it out here because we are going to learn how to take common factors further. Now we will study special product formulas. This you will use it throughout your mathematical career. Maybe it may be like however far you reach, like in this mathematics, whether you are conducting research or something, you use these formulas for throughout your mathematical career. So I strongly, very strictly recommend you to learn all these formulas by heart. First one, what if you multiply a plus b into a minus b? Okay, and in all these formulas, a and b belongs to R. That means they can be any real numbers. What if you multiply two binomials of this form is equal to a square minus b square? How to prove this? So that is nothing but apply FOIL, because you are applying, you are multiplying two binomials. So you can apply the FOIL method that I taught you earlier. A plus b into a minus b. If you apply FOIL, the first terms are a and a, so multiply them, you get a square. Outer terms are a and minus b, so if you multiply, you will get minus ab. And inner terms are b and a, so if you multiply them, plus ba. And last terms of each expression is b and b, therefore if you multiply them, you will get negative b square. And because you are in real domain, ab is equal to ba, that means plus minus ab plus ba is 0, therefore you are just left with a square minus b square. So that is how you prove it. Next, second one, a plus b the whole square is equal to a square plus 2ab plus b square. You should pay lots of attention. This is not same as this. Okay, a plus b whole to the power of n is never same as a to the power of n plus b to the power of n. So sorry, if there is a plus sign here, it will never be same. Okay, the proof is similar as you should do the FOIL method for a plus b times a plus b, and you can check that it would be equal to this expression. Third one, a minus b the whole square is equal to a square minus 2ab plus b square. And I am repeating it again and again. It is very important that you learn these formulas by heart. 4, a plus b whole cube is equal to a cube plus 3a square b plus 3b square a plus b square. This can also be written as a cube plus 3ab of a plus b plus b square. But you still haven't learned how to take things common. You will understand this step, the second one, when I teach you how to take common factors out of each term. Fifth one, a minus b whole cube is a cube minus 3a square b plus 3b square a minus b cube. Quiz 1.3.5. Prove formula number 5. So hint is expand LHS and use number 3. This is the LHS. Expand it. You see like how you can use number 3 after you expand, and try to prove it as we proved it for the first one. Now multiply using special product formulas. I told you earlier, like, you are going to learn all the methods by solving as many examples as you can. So pay attention to what I'm doing. This is number 42 in your book. Suppose I consider square root of y plus square root of 2 times square root of y minus square root of 2. You can clearly notice, if you consider the first term as a and second term as b, that is, if a is square root of y and b is square root of 2, this expression, given expression, is of the form a plus b times a minus b. So that is nothing but a square minus b square. So directly applying this, that is number 1. That is the formula, that is number 1. Directly applying that product formula, you will get square root of y the whole square plus square root of 2 the, minus this one. Apply this. Square root of minus square root of 2 the whole square. Now you can see that you need to apply the nth root properties here. N is an even number, so applying property number 5, which I taught you in the previous video, you will get it to be modulus, that is absolute value of y, minus absolute value of positive 2 is nothing but 2. So this is the answer. These product formulas are really helpful when we are simplifying bigger and bigger expressions. Next example, this is 32 in your exercise book. So x minus 3y the whole square. Now this is of the form a minus b the whole square. Okay, did I write a and b to be belonging to R? I guess yes. Yeah, it need not be only R, it can be any algebraic expression also. That's what I'm doing here. It just need not be real numbers, it can be an expression. So here they are nothing but monomials in this case. They can be binomials, they can be trinomials, they can individually be polynomials also. You will see further like how we solve it. So this is nothing but a square minus 2ab plus b square. Now substituting for a and b, a is nothing but x and b is nothing but 3y. So if you substitute for it, you will get x minus 3y the whole square to be a square is x square minus 2 times a is x times 3y plus b square is 3y the whole square. So this would reduce to x square minus 3 into 2 is 6xy plus, xy plus 3y, 3 into 3 is 9, y into y is y square, so 9y square. This is how you expand using the formula. Let me do another tougher one where each term is a binomial individually, or at least one term is a binomial. This is problem number 58 in your book. I have allotted all odd number problems as homeworks, and I'm trying to work out or give example by working out the even numbered problems. Square root of h square plus 1 times square root of h square plus 1 minus 1. So here you need to group this expression again, like taking a to be square root of h square, h square plus 1, and b to be square root of 1, b to be 1. So in that case, the given expression is of the form, again it is a plus b times a minus b, that is equal to a square minus b square. So here is a is square root of h square plus 1. Applying the formula, we get the given expression to be equal to square root of h square plus 1 the whole square minus b square is 1, therefore 1 square, that is nothing but 1. Again here we have n to be even, and applying nth root property, we get it to be mod h square plus 1 minus 1. But you can observe, if you square a negative number, you will get it to be positive. If you square a positive number, you will get it to be a positive. Therefore, h square is always positive. And if you add 1 to it, this whole expression is always positive. Therefore, absolute value of a positive number is h square plus 1 itself, minus 1, that you will get it to be h square. You can do the rest as quiz 1.3.6. first one, multiply, it's common for both, multiply using special product formula. First one, it is x plus of 2 plus x square times x minus of 2 plus x square. This is same as the above example, but your b value is a binomial here. Second one, 3 plus 2y whole cube. Be careful while using cubic roots. You should multiply using the special product formula, and you should by heart them. I am repeating it again and again. So this will complete a part of your 1.3. I will continue factoring of common factors in the next video. I don't want each video to be very lengthy so that you like stop it abruptly and you forget to continue and you miss out quiz questions. I am trying to keep all the videos as short as possible by dividing each chapter into sub-chapters. So do let me know if you have any questions in the office hours. See you in the office hours. Thank you.